Very good evening, everyone. Am I audible to all? Hello, everyone. Am I audible? Okay, thank you for telling me. And yesterday I explained you guys this. We were in middle of something, and that was just a minute. Let me take my touchpad. So basically, in this particular graph, if you see, the connectivity is like N4 connectivity. Okay, that is, you can either like connect with, sorry, not in this graph, but the connectivity can be of type N4, which is you can either connect with your topmost, like an element above you, an element below you, an element on the left hand side of you, and an element on the right hand side of you. So that is known as N4 connectivity. Then comes N8 connectivity. N8 connectivity is nothing but you can connect with an element to its top, bottom, right side, left side, and diagonally also you can check if there is any possibility of a connection. You can also go via that. Are you able to follow this? So if you see here, if you take this particular number, it can connect to this and it can connect to this, considering the N4 connectivity. Then this element can connect to this, and this element can connect to this. So these all elements are connected via N4 connectivity. If you notice carefully, you can also say that it is an N8 connectivity, but mostly it is given in the question that how you need to proceed. Well, like whether you have to proceed via N4 connectivity or you have to proceed via N8 connectivity. Is it clear, guys? Is the question clear? And in this, you have to find out number of island. As I said, the land parts you have to find out. No responses. If you are not getting anything, you can ask me.
Ma'am, once again, can you please repeat?
No, I won't. You have to tell me your exact question. What is your question?
Uh, Number of island is like I can see it is four,
Mm-hmm.
five,
Four, five.
but
Where four, five? Okay, yeah, five connections. Right.
yeah, yeah.
Yep. Then,
But how will we find it? All we have to do is five islands we have to find.
yeah, correct.
And the biggest island.
You have to find out number of island.
Okay,
Hmm.
just the number of islands.
Yes.
And this is a adjacency matrix?
Yes. You can take it as an adjacency matrix.
Okay,
Okay.
yeah.
Any other questions?
And knowing that whether it is a N4 or a N8 kind of setup
Mm-hmm.
mm, will help me in knowing what kind of
How many
surround.
islands are there?
Okay,
It will help you in knowing that.
yeah, but how does this help? Because We just have
See,
to see the boundary.
see, if I remove this and this, I make it as 0, and I make this as 0. And if it is an N4 connectivity, then you will see here that this will become your one island. You can't connect diagonally. So this will become your next island. So total number of diagonals will become here 6. But if in the same place there would have been N8 connectivity, you can connect these elements as well because they are diagonally connected, and then you would have only pipe elements. So this is the difference you get. Like basically you get the difference in the answer when you are following the N4 connectivity or when you are following the N8 connectivity. Make sense?
Yeah, yeah, I got it.
Okay, perfect. So I gave you guys a brief uh, introduction to the graph, and this much exposure to the graph is enough for your interviews and all. If you guys want, like I should explain more questions and all, so you know that I'm always available. You will be having this group for always. So any questions you have or any doubts you have on the graph topic or anything, you can just ping it in the group. So now I'll just leave this topic here and I will start on with bit manipulation. I'm expecting it to be finished by this week probably, but today's Thursday, Friday. So maybe I will take 1 or 2 days more in the next week as well. And the remaining week we can use for the miscellaneous question. And I guess we will be done by this month. Okay. Ashish, try is also a part of miscellaneous topics. It's not that big. So we will just quickly discuss about it. Like basically, I am going to give you the introduction and 1, 2 questions because try is not that a big topic. So it will be finished by then. Yeah, that only I'm going to do. You are all aware of what are bitwise manipulation. What is bitwise manipulation? What are bitwise operators? Anything you guys are aware of? Okay. So if I talk about bitwise operators, they are and, or, XOR, not, left shift, and right shift. Okay, like these are the basic. The one Vishnu you have given on the chat that is double AND. It's not a bitwise operator, rather it is a logical operator. It decides whether your condition is true or not. Like basically it comes under the logical operator, not under the category of bitwise operators. Okay. So quickly, I'll just write few things. You have to tell me what does it mean. Let's suppose A is some number. If I do A's or A, what I'm gonna get? If I do A or A, what I'm gonna get? And if I do A and A, what I am going to get? Same thing, A or 0, A or, sorry, A's or 0, A or 0, and A and 0. This one, and for A XOR 1, A or 1, and the last one is A and 1. These three are like these three columns you guys have to fill and tell me what's gonna be the answers for this. Please be quick. Forgot. Okay, I'll take you. So basically, I'll take A equals to 5, or I can take it as 8. 8 is nothing but 1 triple 0. Do you all know how to find out the bitwise, like how you can convert a number to a binary number? Do you guys know how to convert a number to its binary representation? No. Okay, cool. So it's basically like that since it's a binary series, it follows a progression like 1, 2, 4, 8, 16, 32, 64, 128, and 256. Let's suppose I'll write that. So this is for 256, this is for 128, 64, 42, 16, 8, 4, 2, and 1. Now, we'll see that this number 8 is divisible by which of these numbers? So is it divisible by 256, 128, 64, 32, or 16? No, right? Because they are bigger than 8. But when we will reach 8, it is completely divisible by 8. So we will put 1 here. When it is completely divisible, what will be the remainder remaining? 0. So we will fill the remaining digits on the right hand side of it as 0. Let's suppose I take A equals to 7. Again, I'll follow the same procedure. I'll just like have less blanks over here. 8, 4, 2, 1. So 7, is it divisible by 8? No. Is it divisible by 4? For one time it will go, so 1 I will keep. What will be the remainder? 3. So will it be divided by 2 now? Yes, so I'll get 1 here. Now 1 will be remaining. So 1 is divisible by 1, obviously. So 1 will come here. So your binary representation for 7 is equals to 111 or 111. Getting this? Okay. So I hope you got that how to find out the binary representation of a number. Perfect. So if I took 8 as a number, A XORs A means I take 8 binary representation. I will take 8 binary representation again. I will try to find XOR for that. XOR means if you have same digits in the same place, that means 0, 0 are same, right? So your resultant will be 0. Again, 0, 0 same, 0. 0, 0 same, 0. 1, 1, again the same bits. So your answer will be 0. So whenever same numbers are XORed, you will get the resultant as 0. Clear? A or A. So here for now I will take A as 5. So it's 101 and again 101. If I do the OR operation here, it's basically like if you have 0, 1, then also you get the result as 1. If you have 1, 0, then also the result is 1. If it is 1, 1, then also your result is 1. So here if you get 1, 1, 1, 0, 0 only, so you will get 0, 1, 1, 1. So overall you got the same number. So whenever you do A or A, you are going to get the same number A. A and A means when you have 1, 1, you will get 1. But other than that, you will get 0 and 0. So here you do the AND for this 1 1 1 0 0 0 1 1 1. So it's also going to give you A. Clear or not?
Ma'am, one thing is not clear. Like, are we doing for numbers or like binary numbers only?
Binary bits.
So what is the use? Like, we do it for numbers. Why we do for this bits?
No, when you do this particular operation on a number, which is a decimal number, it automatically on the back end converts it to the binary and gives you the answer, like calculates it in the binary form and then return the result in the form of decimal number.
Okay. So in case of 8 and 8, it may gave me 0. So
This
in
is
case,
XOR,
yeah, XOR. And this is
or
Python, or okay, or
this is AND.
and so in case of OR, uh, 101 and uh, 101. So we just add up.
No, add up, it's not the case. You have to see the bits.
Yeah. So if it is 1 1, it becomes 1, 0 0, it becomes 0, 1 and 1 1 becomes 1.
Yeah.
So this number is uh, 4, 5. So 5 remains 5.
Sorry?
So the number 5 remains 5.
Yeah.
Okay.
That's why A is written, right? If A is or 0, you have to do 1 0 1, and you have to do here 0, and this is also 0, this is also 0. So overall, see, I told you, if it is contradictory 1 and 0, and it is XOR, so you will get here 1. If it is same, then 0. If it is contradictory, then 1. So then again, you got your same number A. If A or 0 is there, then I told you if opposites like 1 and 0, you will get 1. If 0 0 is 0, if 1 0, then 1. So again, you will get A. If you have to do AND 1 0, which means opposites, you will get 0. 0 0 0 obviously, and 1 0 you will get 0. So here you are going to get as 0. Clear?
Yes.
Okay. Now talking about A XOR 1. So your A is, let's suppose, 1 0 1, and here you are going to get 1. Sorry, and you have to do XOR. Same, so you'll get 0 0 and 1. I'm taking another case. Here your A was 5. I am taking a case where your A is 6, which is 1 1 0. If I'll do 1 to here and do the XOR, I'll get 1 1 and 1. So here I am going to get as 7. Here I am going to get it as 4. Did you guys saw that? Yes, no. Okay. Any difference you observed, like what is happening? How should I conclude my result here? The result here is that if your number is odd, that is 5, you are getting the result -1. That is, if I write down the result here, it is A plus and then -1 A mod 2. If it is by any case even, then it will make this entire number 1 as 1 only, not -1, and it will add to your final answer, and you will get this answer if it is even. If it is odd, then it will remain as -1 and hence subtract 1 from your answer, and you will get the answer 1 less than your current answer. Clear?
No, ma'am, it's not clear.
You
Uh,
saw if I did it with 5, I got 4.
yeah.
If I did it with 6, I got,
7.
yeah. So with even, it is giving you +1, and with odd, it is giving you -1.
Yeah.
So I just added -1 to the overall answer and above put a mod 2. So if your number is, let's suppose, odd, so it will give -1 as the result of this particular expression, and overall your answer will be subtracted by 1. If it is even, then overall this expression is going to return you 1, which is gonna add to your current answer and like will increment your answer by 1.
I'm still thinking. Let me.
Yeah, you can analyze it on your own. Next is a or 1. So I'll take a equals to 5. That is 1, 0, 1. And here is 1. When you do OR of it, you'll get 1, 0, and 1. If it by any case it is even, 1, 1, 0, and you have to do OR with 1, you're gonna get this. Are you getting it? With even number, your number is getting added by 1 in the final answer, and with odd number, your answer is the same as your input value. So for this, you can write the expression as a plus 1 minus a mod 2. So if it is even, mod 2 will give you 0 and 1 will be added in case of even. If it is odd, this is going to return you 1, 1 minus 1 will be 0, and overall your answer is going to remain as a only. Now talking about the next and.
So, ma'am, how do you represent this? Like, if it is a plus, like, how, I couldn't understand why do you write a plus within brackets 1 minus a mod 2?
Because I want to add to my answer 1 if my number is even.
Yeah.
So I've written it accordingly. If it will be even, this mod portion is going to return me 0, right? You do mod of 2 with any even number, you get it as 0.
Yeah. So, in that case, it will become one more than the given number.
Exactly.
But if it is odd,
Then it is going to return 1.
okay, 1 and it will cancel out. Okay. Okay, got it.
And here it's 1. And you do and, you will get 1, 0, 1. If you will do it in the case of even, you will get 0, 1, 1. Clear, no? Is it clear or not? Oh my God. Okay. Any confusions here? Just give me a minute, guys. And sorry, guys, I missed one thing here. When you are representing one in the bit manipulation, these will be zeros. And here, 1, 1, it came 0, 0, 0, 1, 0, it is gonna give you 0. Here, 0, 1, 0 again 0, and 1, 0 again 0. So basically, if it is a and 1, so it's mostly like a modulus 2. If it is an even number, you are going to get all zeros. So 0 it will be your answer. If it is an odd number, you are going to get 1. So that is your answer for the odd number. Clear? Is this clear to everyone? Okay, perfect. So let's understand
Ma'am,
what are.
ma'am, one thing, how do we represent it in terms of like a? Oh no, no. Oh, I saw. I'm clear.
Yeah. Let's talk about shift operators. So in the shift operators, you have left shift operator, and you have, like, let's take it as, or let's take it as I, and the other way we have right shift. So let's suppose I'm giving you A as 25. I will just represent the binary representation of 25 with ladders. This is binary representation of 25. Okay. If I do one left shift here, what am I gonna get? 0, 0, 0, 1, 1, 0, 0. If I left shift it by 2, 0, 0, 0, 0, and you will get 1, 1, 0. If I left shift it by 3 digits, and basically, like, you can keep continuing it further. Are you getting it? So if I see it in the form of answer, oh, sorry, that's the right shift. My bad. Um, so previously, like first time it is 25. If you see it here, it's 12. If you see it in the next time, it is 6. And the next time it is 3. So did you observe any chain here? Every time the number, your A, is getting divided by 2 to the power whatever number you are shifting for. So that is overall answer you are getting is A divided by 2 to the power of I. I'm not getting your question or statement.
So every time it is becoming half.
Yeah, half it is becoming. So it's like we are following a sequence here, but if you have to get the answer for A right shift I, it's like A divided by 2 to the power of I. Clear? And there will be a chance or a point where your entire numbers are going to be 0. In the right shift, you get that. Now talking about left shift. So if you do left shift, you're going to get 0. If you see here the representation, it is 5. Here it is 10, 20, and here it is 40. So every time 5 is getting multiplied by 2 to the power of I. Clear, no? This formula may or may not always work because there is a possibility that this I is a very big number, and you know that in terms of bits, you can maximally in int, you can have 32 bits. In long, you can have 64 bits. But if I value goes beyond that, you can see there is a certain limit it can go. After that, it starts overflowing. So it will start giving you the negative value. You can't always trust this formula in terms of left shift on. You need to ensure that what is the value of I first. Clear? Okay. So a very classic question in Bitwise. How to restrict with terms of data type. See, I told you no, that in int, for the integer, you will have it for like 32 bits, and for long, you can have 64 bits. Beyond that, you can't go. Giving you a very classic problem, try to do it by bitwise manipulation on your own. You have to calculate the power of 2 of int n. If I am giving you n, you have to tell me what will be the 2 to the power of n answer. Are you getting it? Okay. Can you write for it the code? Okay, it's perfect.
So all we have to write it is a left shift operator to raise is to multiply it by 2 for this.
See, if we are writing it for a bitwise, but like using bitwise manipulation, then you need to think, okay, how can I use the bitwise operator to do it?
Correct.
Okay, so you need not do it via the iterations and all. Try to do it using some operator. Because everyone know that, okay, they can find 2 to the power n via iteration. So we do not need that.
Right. So the question is about squaring a number.
You need to find out 2 to the power n. If I'm giving you n, I need the value of 2 to the power n.
Okay. Okay, I'm thinking about it.
Yeah. So not 2 exactly. You saw that when it's a and you do the left shift for it, it's a multiplied by 2 to the power of I. So you are getting 2 to the power of I already, and here a should be 1 only. We do not need any more than this. So it should be a left shift 2 to the power of, sorry, my bad, a left shift n, and that's it. If you will do 2 left shift n, it will give you 1 extra 2, which is not required. Okay, for like, see, you have written here long because you know that the value can be bigger. But since in the return you have written 1 only, we'll take it as an integer value. So for long answer, you need to write it as 1L. Then only take 1 as a long value and calculate your answer properly. Next is you need to find the power of, like, let's suppose I give you int a, that is any number, and I say that, okay, find out 3 to the power 6 or find out 7 to the power 8, whatever. So you need to implement this particular solution. Clear?
So we have to do a to the power n.
Sorry.
Calculate.
Yeah, a to the power n you have to find out, and how you're going to find it out, you need to tell me that. Okay. So this will be your homework, kind of. And okay. Once you are able to do it, no, it's not a n. It's not that. It will be then a into 2 to the power of n, right? Are you getting it, Ashish? And we do not want. So you try and test it today. I have given you the basics of Bitwise. Tomorrow we are going to deep dive or see more and more questions on Bitwise tomorrow. And yeah, we'll see it tomorrow. Okay.
Ma'am, link of this
Yeah, I'll share that.
and is bitwise important for the interview?
Bitwise is more important for the competitive coding, but from interview point of view, you should know the basics, but they don't deep dive much into your Bitwise skills. It's mostly for your programming, like bettering your programming perspective.
Okay.
Okay, so thank you guys for attending the class today. I'll drop off now and we'll see you all tomorrow. Bye bye.